Hey everyone, and welcome to this video on volume, part of the year 12 general maths, but basically from about year 4 and onwards, still really useful. My name's Darren from Maths Guru. Thank you very much. You're going to say Maths Guru. I'm going to say, yeah, down there, maffsguru.com. My little corner of the interweb where I've got a website with loads of videos and downloadable notes and questions and exam questions and so much more. If you can do me a massive favour, though, I also have a YouTube channel, which may well be where you're watching this through. If you can subscribe, that would be awesome, all right? Very few people watch these videos, and every time someone subscribes, it really does mean the world to me, because as I said in a previous video, if you can see the dog right now, he's lying there, and I'm talking to myself in a room, going ever so slightly mad. So if you click that button, then I basically will continue this and go, there is someone else watching these videos except my mother. All right, so enough of that whingy, whiny stuff. I'm also on social media. I know, random, huh? Learning objectives, I'm fairly sure you guys can read those, but we're going to look at volume, basically stuff you've done before. Now, as we continue through the section relating to measurement, scale, and similarity for year 11, and although I say it's year 11, you guys can actually watch it at any year level. We've done all the work on 2D shapes so far, haven't we? It's all been 2D shapes, but now we're going back to food. Everything I do in this is food, food, food. And coming up to Easter, we're getting towards celebrations, and I was wondering one day how many chocolates can actually fit inside a standard box of celebrations. I'm going to leave that to you because they don't last long enough for me to count them, but you know, obviously that is a 3D container. And if we're being asked to find the space inside those 3D containers, then life is good because that's effectively the volume. Now, we try and trick you a little bit later on by capacity, but that's really when we fill things up with liquids. So when we're filling shapes up with liquids, we try and find the capacity. Otherwise, we try and find the volume. And again, there's really subtle difference between the two. For the course we're going to do, we really need you guys to be able to find the volumes inside a number of common shapes. So for example, as I say here, rectangular prisms, square prisms, triangular prisms, cylinders and spheres. And a prism is a phenomenal shape, all right? I need you, as I said a moment ago, to just realize that when you are working out capacity, it deals with fluid. So whenever they say that you're going to fill something up with water or liquid or, I don't know, blood or whatever else. Horror movie. Anyway, when we're filling it up, you always work out the volume in meters cubed or centimeters cubed first. So whatever shape you have, it doesn't matter what it's going to be filled with. If it's a cylinder, you can actually find the volume first in, let's say, meters cubed or centimeters cubed. Then you're going to put this in your summary book, and thank you very much to Cambridge for allowing me to use this. You are going to then say, well, hold on a moment, 1 meter cubed is equal to 1,000 litres. So 1 cubic meter is equal to 1,000 litres. 1 centimetre cubed is equal to 1 milliliter. And 1,000 centimeters cubed is equal to 1 litre. So actually, this one down the bottom, the one I'm highlighting at the moment, is generally the one we use the most. Work out the volume of anything in centimeters cubed, and then divide it by 1,000, and you will get 1 litre. But it's just Barry being a pain in the butt. Now, what is a prism? When I used to work at Tesco's in the United Kingdom, I miss Tesco's, I actually generally wanted to work in the bakery. Why? Because they had the most interesting machine. And that was basically that one there. We'd have old people walk up with this massive loaf that wasn't sliced, and they'd say, hello, my duck, can you do me a favour, please? Can you just, slice the bread? And I'd be like, yeah, I'd love to. I wasn't allowed to because I wasn't trained. And basically, the people who were trained would take it in to this massive machine with, like, razor-sharp blades, and they would basically push it through, and then the bread would just go, and it would come out perfectly sliced. And pretty much every slice of that bread was exactly the same shape. And that's what I think of as a prism. You're going, what's this got to do with prisms? If I can put a shape through a bread cutting machine such that every single slice will come out looking exactly the same, then it's got to be a prism, right? So if I can slice it, then it's got to be a prism. Another example, Toblerones. Unbelievable. Actually, anyone ever wants to send me presents? No one's watching the videos. Why would they send me presents? Anyone wants to send me presents? Toblerone. Not the white chocolate one. It's good. But the actual, the milk chocolate one is amazing. And for those of you in the United Kingdom watching, oh my goodness, jelly tots. If you have not had a box of jelly tots, Jelly tots are amazing. They're like little sugar, coated in sugar, and packed in sugar, pretty much. So it's just like eating sugar. And I used to eat a whole tube of those. They were massive, in about 3 minutes. And I would literally be like, hugest sugar high I've ever been on in my life. Yeah, my nan, bless her heart, used to buy me 6 or 8 of these every single Christmas. I miss jelly tots. Anyway, what's I got to do with the price of fish? Nothing. But again, that there would be a triangular prism. Because if I was to put this through my bread cutting machine, I could actually slice it along here and all of them would turn out to be triangles, which is effectively what the chocolate is. Likewise with this cylinder, if I was to put it through the bread machine like that, then every slice that would come out would be a circle. Yes, indeedy. So those are examples of prisms. How do we find the volume? Now, lots of different shapes. Say stupid thing. If I have a cuboid, all right, if I have a cuboid here, lots of people go, oh, the volume is the length times the width times the depth. Yeah, okay, I get that. But once again, if you choose one corner of this shape, you'll notice you've got 3 lines coming off of it. All right, I really do need to make the pen much, much thicker. Let's do this in highlighter. They've got 1 line coming off there, 1 line coming off there, and 1 line coming off there. Again, for prisms, I choose one corner and I multiply the 3 lines that are coming off of it. That's one way of doing it. But a much funkier way of doing it, and I said funkier, is this. The volume of any prism is actually given by the area of the front times by how far back it goes. Right? Now, the area of the front has a special name, and it's called the cross-sectional area. Cross-sectional area, because that's really a cross-section. So if I can find out the area of the front and times it by how far back it goes, I've got the volume. And you're going to say, really? Does that work? And I'm going to say, right, well, okay, let's imagine that this here is A, and that is B, and that is C. Okay, so I've just told you if I wanted to find the volume of that shape, the volume would be given by A times B times C, yeah? So A, B, C. Now, let's do the same thing here. I've got A, B, and C. If I know that this is A, and that is B, what is the area of the front? Well, my cross-sectional area is going to be AB, isn't it? Because you're going to multiply those two together. And then I told you that my volume, which is cross-sectional area, times by how far back it goes, will be cross-sectional area times C, which is AB times C, or A, B, C. So they are exactly the same. But this works for all prisms that I can think of off the top of my head. Yep, all prisms, where if you can find the area of the front, or a face, and multiply by how far back it goes, life is good. Now, again, there are common shapes and volumes. I know Cambridge have been amazing, and they've gone, all right, and put these in your summary books, and by all means put them in the summary books. These notes can be downloaded. But again, I want to turn around and say, what is this? The volume would be the area of the front times by how far back it goes. The square prism. Area of the front times by how far back it goes. Triangular prism. Area of the front times by how far. Cylinder. Area of the front, which is a circle, times by how far back it goes. Right, here are some examples. Find the volume of the cuboid shown. Again, I am going to find the area of the front, and then I'm going to times it by how far back it goes. So, my volume is going to be the area of the front, which is 6 times 4, times by how far back it goes, which is 12. Again, let's bring my calculator up. Hopefully you guys could be able to follow this on your calculator. 6 times 4 times 12 gives me 288. Now, the units are really, really important. This is 3-dimensional because we're dealing with 3-dimensional solids now. 288 centimeters, but with a floaty 3. And if you noticed, area was a floaty 2 because it was 2-dimensional. Length is realistically 1-dimensional. So when finding perimeters or arc length, it's just centimeters. Volume is 3-dimensional, and so we have this floaty 3. Find the volume of this cylinder in cubic meters. We can do that because the first thing I'm going to do is find the area of the front. Well, that's a circle. So I'm going to say, he said, rubbing that out, that the volume is equal to the area, which is pi times radius squared, which is 5 squared, times by how far back it goes. And it's going back 25 meters. Again, finding my calculator, so let's do pi times 25, which is 5 squared, times another 25, gives me a very big number, and we want this to 2 decimal places, 1963.5, now 0 meters cubed. I don't actually need that 0 there, so I can get rid of it, and let's move my meters cubed a bit closer. And voila. And now again, if you're not sure how to round to decimal places or significant figures, or use standard form or index notation or standard form, what do we call it? Scientific notation, there is a video for you to watch on mathsguru.com. Oh my goodness, find the volume of the three-dimensional object shown. We can do this now because we know that the volume is going to be the area of the cross-section. In that situation, that's that area there. Well, what shape is that? Yeah, I know. It's a trapezium. Why am I talking to you like you're responding? It's random. Right, so how do you find the area of a trapezium? You add the parallels. So my parallels are 10 and 15. I times by how far apart they are. So my parallels were these there. How far apart today is that? So that's times it by 6. And then I'm going to divide all of that by 2. And I'm going to times it by how far back it goes. Again, times by 25. How am I going to do that? Do it on a calculator. Right, so let's go. Command and divide. That gives me my... Let's do open the brackets. So I've got 10 plus 15. Close the brackets. Times by 6. Divide by 2. And then what do we want? To times that by 25. So again, I'm letting my calculator here do all the hard work. And it comes out to a nice 1875 units, centimeters, and cubed. Again, don't forget cube because it is three-dimensional. And again, it's about knowing the areas of your common shapes, like your triangles, your circles, your trapeziums, your quadrilaterals, all these type of things. Now we're going to do find the capacity. And if we go back to the start of the video, what did we say about the capacity? It's just the volume that we convert into liters. Right. A drink container is in the shape of a cylinder. Okay, so there's my cylinder. Quick diagram's not going to hurt. How many liters of water can it hold if the height of the cylinder is 20 centimeters? And the diameter, oh, they're trying to trick us. The diameter is 7. Now, if we remember, my volume is given by the area of cross-section. So that's the circle, but the area of a circle is given by pi times radius squared. And that's going to be times by 20. Right, so again, there's my area of cross-section, which is pi r squared, times how far back it goes, or in this situation, the height of 20. But what's my radius? It's not 7, it's 3.5. So my volume is going to be pi times 3.5 squared times 20. Right, bring up my calculator. So pi times 3.5, oops, fingers are all over the place today, times 3.5 times by 20. Hit enter, gives me, now what does it want? It wants it to 2 decimal places. Is this my final answer? Because, let me just check, pi times 3.5 squared times 20, yep, gives me 769.69 centimeters cubed. It doesn't want that though, does it? What does it want? It wants my volume. It wants my capacity. All right, so this is where we go and we say, well, we know that 1,000 centimeters cubed is 1 liter. So therefore, my capacity is equal to 769.69 divided by 1,000, which is going to give me, so we're going to divide that by 1, 2, 3. Gives me, and we want it correct to 2 decimal places, 0.77 and liters by capital L. Right, so again, notice there, I worked out my volume as normal using centimeters cubed and then use this here to help me convert because we were talking about fluids. More food, ice cream should come in tubs, but it doesn't, it comes in cones, and anybody who tells me they like that is just wrong. That cone is just rank. Anyway, nobody should be allowed to sell these things. They are gross. Why? Because they should come in old-fashioned cones. But to find the volume of a cone is actually a formula. I'm not going to get too deep into why, because that's like uni maths and then some. But we need to know to find the volume of a cone, you do 1/3 times pi times r squared times h. So what we're saying there is if I have a cone, I need to know the radius and I need to know the height. Now, the height is very important. A lot of people get tricked because they think that this slant length here is the height. It isn't. It's actually called the slant length. We want the height from the highest point down to the bottom of the cone. All right, so here is an example. Find the volume of this right circular cone. Again, it's right circular. They're just saying that basically it's going from the highest point here to the center of the cone there. And again, we say the volume is equal to 1/3 times pi times r squared times h. So let's put the values in. 1/3 times pi times my radius is 8.4 squared, and my height is 15. Can't do that in my head, but I have my calculator that can do it for me. So let's do 1/3. What do we do? Times by pi. Hit enter. I'm going to times that by 8 point. Whoops, I never do this. 8.4. Let's use the squared button this time. Squared. And I'm going to times that by 15. Hit enter. Gives me, correct to 2 decimal places, 1108.35. My units are centimeters. It is a volume, so it has to be a floaty 3. Ka-ching! Now, I'm not going to get too deep into this because as far as I'm concerned, that is a correct shape football. I do not know what that is in any way, shape or form. All I know is that when I kick that, it goes in a straight line from A to B. I kick that to someone, it goes like this. It literally bounces all over. And I suppose some of the most amusing times I have is lunchtime duty, watching people chase these things, trying to second guess where they're going to go. No, yes. But again, it's another formula. If we want to find the volume of a sphere, and this thing here is called a sphere, or it is spherical, is given by 4/3 pi r cubed. This should go in your summary book, guys. If it isn't already in there, put it in your summary book. So important. Shall we use it? I should cocoa. Let's come up with an example. So we want the volume of this sphere. Now you'll notice again, it was, let me just try and remind myself, 4/3 pi r cubed. 4/3 times pi times r cubed. For some strange reason, my brain never remembers this one. So 4/3 times pi times my radius of 2.5, and this situation cubed. Right, and again, this is a nice and easy one. The only thing we need to know here is my radius. Shall we do it? I should cocoa. So let's go 4/3 times pi. Now I can actually on my calculator type pi, and it'll do it. I can do 2.5. Now, if you're not sure where the floaty 3 button is, use this caret symbol, and then you put the floaty 3. All right, and there we go. So when I do that, it gives me 65 point. What's my decimal places? 2, 4, 5. Units are centimeters, and because it's volume, it's a floaty 3. Believe it or not, again, that's the end of that video. Hopefully it has been helpful for you. Again, how do they try and trick you with these questions? They do silly things like find the volume of a hemisphere, and a hemisphere is basically half a sphere. All right, now if you're finding the volume of a hemisphere, find the volume of the whole sphere and then literally divide it by 2. Makes life really, really easy. I'm done. Thank you very much for watching. If you can, head to mathsguru.com, subscribe.com, I should have said, and subscribe. Head over to Maths Guru, subscribe. Social media, subscribe. There's lots more videos coming. I feel like I'm just blabbering now. Thanks very much for watching. I'll see you in another video. Take care, guys. Be safe.